cars passing the same direction side to side pass the traffic light simultaneously. Car A is traveling at 10 with acceleration 3. Car B is traveling at speed 20, acceleration 2. So I like to draw myself a nice little diagram. And I'll go car A, you're now the blue car. Car B, you're now the red car. Enjoy. So they pass this line now. Who's going faster? B. Has a U value of 20, but an acceleration of 2. Car A, U value of 10, acceleration of 3. So long story short, B will pull a gap onto A. A has superior acceleration and will eventually go faster than B. It will catch it back up and overtake. Are we all agreed with that sentiment? All good? Okay. Find the velocity of each car at time t. All right. No hassle. V equals U plus A t. So velocity of car A, we'll call it V subscript A to indicate that we're talking about car A. And it will quite simply be 10 plus 3t. I'll turn my t's into capital T's because they look like pluses. No other reason. Velocity of B, guys? Anybody? 20 plus 2t. Okay. Distance traveled by each car. Once again, in terms of t. What equation do you think I should use and why?
V squared equals.
Now, V squared equals U squared plus 2AS actually has no t's in it. So therefore, if you write in terms of t, your equation you use has to have a t. So we're going for ut plus a half at squared. Agreed? Okay. Next thing, we're going to call it S subscript A. So what's that going to get you? So 10t plus a half of 3. So 3 over 2 t squared, or 1.5, absolutely. Now what about SB? 20t, yeah. Half of 2 plus t squared, yeah. And all that work, like this could be like a Lebenslauf question, and all those forms you got all count as attempts. So you might be on 6 out of 20 or 6 out of 25 just for making your formulas, because you have the access to each thing. Now here's the hard part. Find the time at which they're traveling at the same speed. So what do you think you do there?
Both the t's equal each other.
VA equals VB. VA equals VB. So what do I do? Put these two formulas equal to each other. Let's do that. So we go VA equals VB. So we go 10 plus 3t equals 20 plus 2t. And what do we get?
10 equals t.
T equals 10. Now, I'm going to set up another question in between these two questions. I want to know, what is the maximum lead? Yes.
How did you find t equals 10?
Okay, so see this blue equation here? It's a linear equation. So I did 3t take 2t equals 20 minus 10. And I got t equals 10. Yeah, right, though. I skipped steps. Okay. I'll try not to do that. We all good? T equals 10. Now, what I'm going to ask you is, are you listening? What's the greatest lead? Because after this time, he's going to close back up again, isn't he? Because he's going faster now, yeah? So what we do is CSA and SB. You find the distance traveled by A by subbing in t equals 10. You find the distance traveled by B by subbing in 10 as well. Which car do you expect traveled further? Why did B travel further? Because it was going faster initially than A was. So it should have the bigger distance covered, shouldn't it? So what do we get when we put them in? 250 for A, and for B, 300. So what's your maximum lead? 50 meters is your maximum lead. And after this, your lead is going to get whittled away now, isn't it? Because the car A is now going faster than car B. So that lead's coming back down again now. It's no longer going to be 50 meters. Now, we're asked for the times when they're side by side. Now, what did I say earlier when we were doing that bike thing? When he overtook me, what was the common feature? We both travelled the same distance. SA must equal SB, which means put the two equations equal to each other. So you got t squared plus 20t equals 3 over 2 t squared plus 10t. And then we can double both sides to get rid of the fraction if you want. Whatever you want to do. We're saying SA, the distance covered by A, equals the distance covered by B when they're overtaking each other. So I suppose what I'll do is I'll bring it over this way and I'll just get a half t squared minus 10t equals 0. I'll multiply by 2. And here we go. We all expect the overtake to take longer than 10 seconds, don't we? Why do we think the overtake has to take longer than 10 seconds? They're not together at 10 seconds. They're doing the same speed at 10 seconds. And then after that, A is going faster than B and closing in. So the answer always had to be bigger than 10 seconds. So that's a guideline process. You already know that if you get an answer smaller than 10, you're wrong. Now, there's two answers. The first answer is t equals 0. Why is one of the answers t equals 0? What's the physical reason, though? At the beginning of the question, they both started off at the same point. So their distance was the same at that point. That's your t0 explained. And then t20, t equals 20, anybody? 20 seconds later, the overtake occurs. When you solve quadratics, there's two numbers. There's the number in the purple box and there's the number in the dotted pink box. One of them has to be responsible for being 0. So either t is 0 or t minus 20 is 0, which implies that t must equal 20. Okay. Okay. Standard distance time question, isn't it? Very standard. And 1 minute, so 60 seconds total. 12 seconds. 8 seconds. Leaves the middle 40, doesn't it? Okay. Tells us it's 1,000 meters. Agreed? So it's very similar to the question we did earlier. You just get the area under the graph and put equal to 1,000. So a half of 12v, a half of the area of this one is 6v, isn't it? Because it's 12 multiplied by v and half it, so the area of a triangle. The area of the rectangle is 40v. And then the area of the last triangle is 4v. Results in 50v equals 1,000. Results in a v value of 20 meters per second. And we got 20. Hooray. Now, as I was leaving A, another train passed it, moving in the same direction on a parallel track with uniform speed 14 meters per second. After how long and how far will an overtake occur? Neglect the length of the trains. Oh dear. All right, so what I'm thinking is, I have an idea. Okay, so my first idea is that the homework's on Simon's anyway, so you're good to go. Now, would everybody agree? How far did we travel in the first 200? So we traveled 240 meters. Agreed? Yeah. Okay. So Either the overtake could occur anywhere. Would you agree with that? It could overtake in the first 240 meters for all we know. Huh? Oh, it's 120. Thank you. It is 120. So would you agree that the overtake could happen in any of the three regions? Agreed? So let's take it region by region. What I'm going to do is I'm going to experiment with the with this train here. Uniform speed, yeah? U is 14, phi is 14, A is 0, S is I don't know. How long did it take us to get out the acceleration phase? It took 12 seconds. Okay, I'm going to put 12 in here. You ready for that?
Yeah.
Now, I'm going to find the distance covered. It's actually quite easy. Because it has no acceleration, it's simply, what is it? It's velocity multiplied by time. If you want, you can use S equals ut plus a half at squared. But clearly the A value is, so you're just going to say S is 14 multiplied by 12. S is 168. Agreed? Has it travelled further than that one? It has. It's travelled further, which means the overtake has already happened. Happy days. The overtake has already happened. So now we're going to go through the same thing we did last time, all right? So we're going to go through the same system. Train A and train B, we're going to do UVAST for. So train A, and it happens in the first 12 seconds. We know that now, don't we? So its U value was 0. Its phi value we don't know because we don't think it's going to get that far, do we? It won't get to the 20 meters per second, will it? Because it's already been overtaken. Ain't going to make it there. Its A value? Well, we can get the A value. It's 20 divided by 12. What's 20 divided by 12? 5 over 3. I'll take that action. The S value we'll call X, and the T value we do not know. Agreed? Now, what about the train B? Train B, anybody? U is 14. Phi is 14. Its A value?
0.
Its S value? But they're overtaking each other. It's also X. T value? We don't know. But what we do know is that the T values have to be the same. So, remember what I said earlier when we're acting out the scene with the bikes? What happens at overtakes again? S1 will have to equal S2. And what is S1? Let's run our formula. UT plus a half AT squared. Yes.
The two T's are equal, but like, since you have different speeds, wouldn't they like cover the distance in a different time?
That right in there. Guy who no longer does the subject. As it was leaving A, so same starting T value. They're travelling for the same amount of time. Yeah. See the first couple of lines? Means same starting value of T. So they're travelling for the same amount of time. If there is a time lag where I start one of them 2 seconds before the other one, just use T and T plus 2. And then you can still equate them to each other. Yes.
Like in the leaving cert, like, will they ever ask like?
Okay. Now, here we go, guys. You ready? Shh. 14T for S2. For S1, it's UT. UT is 0. A half AT squared is going to be 5 over 6. What was it? A half of A. And then I just had to solve this, don't I? Cancel one of the T's. That's T equals 0 is gone. Multiply it by 6. So it's 84 divided by 5. That's your time. And then what can you do with that? You can put it back into 14T because every second you're traveling 14 meters. So what's 14 multiplied by 84 over 5? Anybody? I'm running out of time. I have a minute. Go on, what you get? And in decimal? 235.2 meters. Yeah,